Welcome to KCC Diesel Online. My name is Jeff Rush, and this is DST 110H diesel batteries or automotive batteries. All right, our objectives really are to learn how to work safely around batteries. Batteries do have an awesome power of destruction. If abused, they will blow up, they will swell, they will spit acid at you, especially once we get into hybrid batteries and things like that. So we try to really exercise safety when we're working around our battery. We're going to explain the fundamentals of how a lead-acid battery produces voltage. We'll describe the series aiding and series opposing voltage source connections. And then we'll explain the process of battery discharging and recharging. And we'll explain how internal resistance affects battery terminal voltage. We'll define the typical battery ratings, such as the cold cranking amps or CCA, and the reserve capacity of a battery. We'll safely recharge a battery using a battery charger. And we'll talk about the tests for conventional and low maintenance batteries. And then we'll talk about jump starting a truck using the correct procedures. We'll also look at a service. We'll look at servicing a battery box, how to properly maintain the cables and clean and tighten cables. And then we'll discuss lithium-ion batteries utilized in hybrid vehicles. Sulfuric acid is a hazardous substance that can cause blindness and serious chemical injuries, chemical burns to the skin. Always wear approved eye protection and protective clothing when handling, charging, or servicing or testing batteries. So make sure you're well trained before you go into the battery box and start trying to do maintenance or tests on batteries. All right, a battery supplying a current to a circuit is said to be discharging. So when we are putting out a current, we are discharging the battery. Conventional current flow is from the battery positive through the load and back to the battery negative. That is our conventional current flow. When a battery receives current flow in the opposite direction of flow, it is said to be charging. So an alternator is typically used to charge a truck or automotive battery. So here's a battery recharging. So if you look at a battery being recharged, our current flow is going into the positive and through the system. So we are actually charging back to the positive side. Okay, and that's an interesting concept. It's not something we really deal with a lot as far as how the actual flow happens, but we do need to make sure the connections are good. All right, four main functions of a truck battery. Batteries supply electric current when the truck engine is not running. Batteries supply current to the engine starter motor. Batteries supply current flow when the engine is running and the electrical load exceeds the alternator output. And batteries stabilize the electrical system, smoothing out voltage spikes. Internal battery components. So the lead-acid batteries are filled with electrolyte, which is a mixture of water and sulfuric acid. Battery plates are submerged in the electrolyte. Positive battery plates are constructed of lead peroxide, PbO2. Negative battery plates are constructed of sponge lead, which is just the Pb. The grid for both negative and positive plates are usually made of lead calcium. So here's a picture of those two plates and kind of how they look inside the battery. So here's another picture, kind of a little bit better explanation. So we have our plate straps, and so we have our negative group here and we have our positive group here, and in between the plates there are separators. And these separators are both to isolate them electrically, but also to allow the electrolyte to flow up and work in between those plates. Series and parallel voltage sources. Voltage sources connected in parallel positive terminal to positive terminal and negative terminal to negative terminal, we'll assume a common voltage. So this is what we do in our trucks. So we put our batteries in parallel. So we end up with more amperage but the same voltage. And then voltage sources connected in series, positive terminal to negative terminal, will produce a voltage equal to the sum of the individual voltage sources. So when we do this different style, we will end up with twice the voltage and the same amperage. So battery cells connected in series. 12-volt battery cells are approximately 2.1 volts each. There are 6 cells connected in series. The total voltage for the series connected cells is 12.6. So even though it's a 12-volt battery, it is completely charged when it has 12.6. If it has more than 12.6, then we worry about having a surface charge, which is really just a superficial charge that's left over. It's not really an indication of real battery charging or the state of the real state of the battery, but just the superficial surface charge of that battery. When a battery has 12 volts, it is considered discharged. So that's the same with your household battery. So if you pick up a 9-volt battery in your house and put your multimeter to it and it reads 9 volts, that battery is on its way out. It may still function. It still may do what you need it to do because maybe you had more battery voltage than you actually needed for that component. However, it is considered discharged at that point. All right, so let's look at the discharge chemical reaction. So our positive plates here are the PbO2, and the negative plate is just our regular sponge lead. And while we are discharging, we are moving hydrogen and the sulfur dioxide this direction. Okay, we're moving it to the other plate. So these chemicals are going to move. Now, when we are charging back the other direction, we are going to be moving that lead back the other direction, and that's pretty significant. Okay, so we really want to know that we are doing the right thing while we're doing that. Okay, so batteries become sulfated, and we know that if a battery becomes all the way discharged, that's called being sulfated, and then we have to charge them slowly and properly in order to desulfate the batteries. So here's what the battery case looks like. Now, before we showed you one cell, okay, and that's that negative and positive pack put together. And then each one of those slides in here, so each one of these slots is going to account for 2.1 volts to make up our 12.6. So we have 6 cells, each having 2.1 volts. All right, so we have different battery types. And so as you do your reading, you're going to see that there are, your post terminals, your stud terminals, your side terminals, and then each one of these batteries comes with a style, a group number. There's lots of different ways that we categorize battery size. Its height, width, depth, and then of course the terminal types. So most truck batteries are class 31 or group 31 batteries, I should say. Connecting multiple batteries, so two 12-volt batteries connected in parallel, positive to positive and negative to negative, have 12 volts with higher current. So if you had two 1,000 cold cranking amp batteries that had two 12-volt 1,000 amp cold cranking amp batteries, you're going to end up with 12 volts, 2,000 cold cranking amps. Two batteries connected in series, positive to negative, will have 24 volts with the same current. So if they were 1,000 cold cranking amp batteries, you'll still only have 1,000 cold cranking amps. Two 12-volt batteries connected in series can be connected in parallel with two more 12-volt batteries connected in series to get a higher current. This is a series parallel connection. This is kind of a little bit rare, but let's talk about it. So 2 batteries connected in series. Okay, so now those 2 batteries are connected in series. That's going to give us 24 volts. Connected in parallel with 2 more 12-volt batteries connected in series. So now we're going to get we're going to get more cold cranking amps out of that. So we're going to have the higher voltage and the higher cold cranking amps. So, you know, you're going to see that in heavier duty applications, maybe not in the commercial trucking industry at this time, but you may have seen it. You may have seen it a little bit in the history of our trucks. You may have seen this, or in military applications, you may see this, military or construction, earth moving. But those are not the common over-the-road trucks or automotive applications. All right, internal resistance of a battery. So simple, this example here in 5-20, simple series circuit with 2 resistors illustrating battery internal resistance. So here's our 12-6. We're coming out. We have our current flow. We've got resistor number 1, and then we've got resistor number 2. And so we end up with 4.2 volts and then 8.4 volts. High internal battery resistance is going to basically be the same thing. And I'm going to let you guys do the reading on this, and then we'll kind of talk a little bit more about it in lab. But you're gonna have that current flow, and you're gonna have a resistor, and you're gonna end up with internal resistance inside of this battery, and it's gonna have this effect of lowering our voltage. Excuse me. Cranking requirements versus battery capacity in cold weather. So let's talk about this. So at 80 degrees Fahrenheit, our battery is at 100% charge, and our the cranking requirement is 100% of that battery charge. And so we should start fairly easily. We're pretty well matched. Now at 32 degrees, our battery goes down to 65%. But our cranking requirements go up to 250 because of that oil being so cold and everything being constricted and tight. So, you know, now we're at a little bit of a disadvantage. And then as we get down to 45%, as we get down to 0 degrees, we're at 45% of our battery and 350% of the normal cranking requirements. And so this is where we end up with a cold weather no start if we don't have a block heater or do something to mitigate that concern. A battery that is frozen must never be charged or jump started because it could explode. Batteries must be thawed to room temperature before charging. So what do we call room temperature? About 70 degrees, 60, 70 degrees at least. Okay, and that battery must be thawed, not just put in a room at 60 degrees. It actually has to thaw as well. So at that point, we can take off a cap and we can actually measure the internal temperature of the electrolyte to make sure that it is, in fact, thawed. Battery ratings. So we have some different battery ratings. We have cold cranking amps, the amount of current a battery can supply for 30 seconds at 0 degrees Fahrenheit and maintain 1.2 volts per cell or 7.2 for a 12-volt battery. Cranking amps is the amount of current a battery can supply for 30 seconds at 32 degrees and maintain 1.2 volts per cell or 7.2 volts for a 12-volt battery. Now, reserve capacity, a little bit of a different number. The reserve capacity is the amount of time a battery can supply 25 amps and not drop below 1.75 volts per cell or 10.5 for a battery, for a 12-volt battery. So, as we look at this, this can cause some concerns. Okay, so this is why we have starting batteries and running batteries and marine batteries, and there's different types and different fits for different applications. So here's that that BCI number, that battery series. Okay, so we'll talk a little bit about that. So what does BCI mean? Okay, so we want to know what that BCI stands for. Okay, Battery Council International. These are the group numbers. So these are the guys that are basically trying to regulate battery size, so that if you go buy a battery at Walmart and you look it up by application, so if you look it up a 97 Ranger with a 2.3, it's going to tell you you need the right, you need this battery, and it's going to be the right height and width and everything for your application. All right, battery recharging. Charging current flow to the battery must be opposite of discharging current flow. Okay, charging voltage must be higher than the battery voltage. The current supplied to the battery for a period of time is expressed in ampere hours, okay, amp hours. During the recharging, some electrolyte is converted into hydrogen and oxygen, okay, both of which are flammable. Hydrogen and oxygen are flammable. If a battery is charged at too high a current rate, it can overheat, warping the plates, and lose an excessive amount of water, and even explode. So you want to be very careful not to overcharge batteries. All right, direction of current flow in a charging circuit is opposite of that when the battery is being discharged. So here is that generator, okay, or our alternator, and it is charging in reverse to our regular current draw, okay? And so we are charging that battery. We are sending positive voltage back down to the battery. Battery recharging safety. When a battery is recharging, explosive hydrogen gas is given off. Jewelry, tools that can make contact between the positive and negative posts of a battery can cause severe burns. So we want to be very careful about any kind of jewelry we wear. I certainly recommend zero jewelry. I've taken all my jewelry off for years. I don't wear my wedding ring. I don't wear bracelets. I don't wear, I have a 550 cord bracelet that's got a metal clasp on it. I don't wear that. Just about anything you can think of that's metal could cause a problem there. Gold necklace chains that contact a battery while working can turn to molten in a flash and leave a scar, as well as just do some serious damage. Make sure that the AC power cable to the charger is properly grounded, so it has that third prong, because if anything does happen internal to that battery charger, you want to be able to send that to ground and not to you. You don't want to be the path of least resistance. The ground terminal on the battery charger, so here we talk about that one. And if you don't have that, then you want to put on a ground adapter, and then this, instead of having a third prong, it'll go into this screw, and then hopefully into the outlets, the plate inside the wall. All right, battery charger connection. Always switch off and unplug the battery charger before making or interrupting any connections at the battery. So we don't plug this thing in and then try to go up to it. We plug it, we connect it and then plug it in. So the last thing we should be doing is plugging the battery charger into the wall outlet. Switch the battery charger to the appropriate setting. Reverse the order when disconnecting the battery charger. All right. Battery testing. So battery specific gravity is the weight of the volume of any liquid compared to the volume of water. So the volume of any liquid compared to an equal volume of water. Specific gravity testing is a bit antiquated. We don't use it a lot. It is a very scientific test. However, it doesn't tend these days to make a difference on how we do our job and how we charge the batteries. With so many automatic chargers out there and things like that, we tend to kind of cavalierly charge these batteries and not worry about specific gravity and things like that. We do want to check temperature and things like that. So Electrolyte is a mixture of 36% sulfuric acid to 64% water, which equals a specific gravity of 1.256 to 1.28 at 80 degrees. So this is something you kind of want to have to memorize during electrical class, so that you can pick this number out of a lineup. And by a lineup, I mean out of a multiple choice question. It is going to be on your electrical ASE test. So when specific gravity is measured with a hydrometer, it must be compensated for temperature differences above or below 80. A refractometer can also be used to measure specific gravity, and we actually have a tendency to use more refractometers in this program than we do hydrometers. All right, so here is measuring specific gravity with a hydrometer. Okay, and so we're going to suck the fluid up, and then there's a thermometer inside the hydrometer, and then we'll figure out what the compensated reading is. Specific gravity temperature correction, and so we'll go through a little bit of this. I'll let you read through it. So we're adding 0.008 specific gravity. We're subtracting 0.024 specific gravity, and it's just going to depend on what we end up with. All right, measuring specific gravity with a refractometer. So we'll go over this in lab, but it's a little bit of a different scale. Okay. And as you see, we don't have as much compensation for temperature with this method. Okay. Low loss water batteries do not have access to the cells to test specific gravity, so different types of low maintenance batteries. Many low water loss batteries have a built-in hydrometer. A built-in hydrometer only indicates if the battery state of charge is above 65 in one cell. Green indicates at least 65% charge. Dark indicates 65% or less, and clear indicates low electrolyte level. These are great on new cars and new batteries, but once the battery is put into service, I really don't recommend using these as a diagnostic method. It's really indication only. But it's not a diagnostic method. If I see a green light there, that really just means that, remember, it's only measuring one cell, so that doesn't mean that you don't have a bad cell somewhere else in the battery. So here's a little bit of a demonstration of what those look like. All right. Surface charge. A surface charge is hydrogen bubbles that form on the plates of the batteries. These bubbles rapidly dissipate when the battery is discharged. The surface charge causes higher than normal voltage. So we talked a little bit about this in our last video. So when you see this surface charge, something over 12.6, something as simple as turning the headlights on for 30 seconds and turning them off will kind of take that service charge off the top of the battery. There also will be instructions with our battery testers to kind of shock the battery real quick just to knock that surface charge off. A nearly discharged battery can appear fully charged with a surface charge. And one of the ways to get a surface charge is to take a completely dead battery and put it on the charger on high, and it will pretty much surface charge the battery, not do any desulfating, and make the bad battery look good. All right, open circuit voltage test. Now this is where we are taking our multimeter and we're going, red to positive, black to negative, and we are measuring our voltage. So 12.6 volts or more is a fully charged battery. 12.4, 75%. 12.2, 50%. 12.0, 25% charged, and then 11.7 or less is completely discharged. So earlier I said, a 12 volt battery is pretty much discharged. It really is, depending on what you're trying to do with it. It's not going to do much for you at a 25% charge. All right, carbon pile load testing. So here's one method of testing the battery. So we're going to check volts and amps and we're going to actually load the battery. We're actually going to put a huge load on the battery and watch our voltage to see if it drops below the specified level. And then the way we tell how many amps or how much load we're putting on the battery is right here with this inductive pickup. All right, battery charging posts. So on a lot of our stud batteries, our battery clamps will not clamp down well enough onto our battery to do proper charging. So we'll actually use a stud adapter like this to help us properly charge that battery. Temperature versus acceptable load test chart. So temperature versus acceptable load test. So at 70 degrees, our battery should not drop below 9.6. And then 60, 9.5, and so on and so forth. As we get down to around 10 degrees, our battery will go down to about 8.7. So when we put our load test with that load tester from the last picture, that's what we're looking at. That's what we're looking for. We're looking for that voltage to not drop below 9.6. And if it does, we call the battery bad, or it needs to be recharged. But we really should not be testing dead batteries. We should not be load testing dead batteries. If you find a battery that is at a low state of charge or has a low electrolyte level, you really do need to charge that battery slow and full to make sure that it is charged before you test it. This is why a lot of companies, when you go in to like Les Schwab and things like that, they offer you a new battery because you're on a time constraint. So you go in with a dead battery, they're going to offer you a battery because otherwise the only other choice they have is to slow charge your battery over a matter of hours and then retest. And so now if you've slow charged your battery and you find out your battery fails, then you've just wasted 4 hours on the charger and you're still buying a battery. So that's why some of the methods for battery charging or battery testing and charging have changed, because we typically, if we suspect a bad battery, it's almost faster and easier to go ahead and replace that battery versus charge and retest and spend all of that labor hours. Now, when you're working on your own car, of course, you're going to want to put that battery on a smart charger, try to desulfate it, try to save it. I'm famous for running batteries that have lower than the specified cold cranking amps. So if I put 1,000 cold cranking amps in my cold cranking amp battery in my truck, and then the battery is now showing only 800 cold cranking amps, I'm good all summer. I'm totally fine with that. Now when I get down to the winter, I may have a problem. That battery may not start my car in the winter. I fully recognize that. However, I like to be a little thrifty when it comes to things like that. A lot of batteries will come back from the dead if properly charged, properly maintained, have water added to the electrolyte, things like that. And so we'll talk a little bit about that. So on your screen right now, figure 5-43 is a Midtronics EXP battery tester. Now this is the style of battery tester they're going to be using at International and Freightliner and some of the big truck shops. Now this thing has lots and lots of features. It will test cable drop. It will test all sorts of different functions of the battery and the charging system. Excuse me. And so as you're going along, you'll see that these type of testers, they're fast, they're efficient, and a lot of them are no nonsense. And a lot of these batteries a lot of these testers will say, good battery, charge and retest. And in those moments, I may be tempted to go ahead and clean the cables, put the battery back in, and charge it, and then come back and retest. But oftentimes, customers don't really want that. They really just want to get their truck back. So we end up taking that battery that questionable battery as a core, sending it back to Exide or whoever we're buying batteries from, and putting in a new battery. I'm sure Exide loves that. They charge a lot of batteries and put them back together. If you go to the U-Pullet, a lot of U-Pullets charge batteries and put them up for sale for very, very cheap. So if you're ever in a pinch for money and you need a battery, some of those U-Pullet places actually sell decent batteries. I've ran a U-Pullet battery for about 4 years before I bought a battery, or I bought a car with a U-Pull-It battery in there. I didn't realize it was U-Pull-It battery, but that U-Pull-It battery lasted 4 years before I had any problems with it at all. So that's maybe just a little bit of a testament to battery life. All right, so look at this, connecting jumper cables and jump starting a vehicle. So when we're doing this on a truck, we're doing it a little differently than we do it on a car. And so we'll kind of cover the cars a little later. We'll cover that in lab. We'll also cover jump starting a truck in lab. So here we go with this. So you're jump starting a truck, and so your first connection should be to the booster battery bank. Your second connection should be to the discharged battery. Your third connection should be to the negative on the booster battery bank. And then the fourth connection should be to the frame. So hopefully that makes sense. We'll kind of go over that. All right, so battery connections. We're going to draw a diagram, mark, and take digital photos prior to disconnecting batteries. Let me say that again. When you're disconnecting batteries, you're going to draw a diagram. You're going to mark the battery cables, and or you may do all of this, and or take a digital photo prior to disconnecting those batteries. Your smartphone, okay, is a huge tool in the diesel industry. You can take pictures. I highly recommend it, because let me tell you, it only takes a second of hooking up a battery cable backwards or hooking a power to a ground to fry a module, fry an APU, fry a inverter or a converter, and you don't want to do any of that, okay? So you got to be careful when you're in the battery box that you are actually doing the job correctly. Be very, very careful. Okay, disconnect first and reconnect last all the smaller cables that are attached to the battery connections. Okay, so we're going to do this last. For one, we want them on top of the battery interconnects and on top of the big cables. So we don't want them under, we want them on top. And you'll see why when you start to do these battery services. Before disconnecting batteries, make sure everything on the truck is turned off. We don't want any sparking or arcing, and we don't want any voltage spikes or anything like that. So we make sure that everything is turned off. Make sure the headlights, the key, all of that are turned off. Remove the negative cable first. Connect the positive cable first. Then we will usually always be a small spark when the ground cable's connected. Now, even with everything off in the truck, we still have things that are pulling milliamps on the truck. When you hook things up, modules will try to wake up and things like that. So there'll always be a little bit of a spark, or it's very usual, very, very normal to have that happen. So don't be alarmed if it does. All right, removing the label to access filler caps on low maintenance batteries. This is an industry standard, okay? So when you get that low maintenance battery, it looks like they're really trying to keep you from maintaining that battery. And truly they are. They don't want you fussing with their battery. They don't want you messing around. And would it make them happy if their battery went dead right outside of warranty, that the battery was used up? Sure. But when we're maintaining batteries and we're doing a battery service, we are going to pull this sticker off. We're going to pull a cap. We're going to do a specific gravity measurement, if that's your kind of deal. And at the very least, we're going to top off the water. One caveat to topping off this water, and a caveat is a cautionary. One precaution while doing this is that you don't top off a dead battery and then try to recharge it, because you will boil that water off. Okay, you'll have electrolyte you'll actually cause more harm than good. So you make sure the water is just above the top of the plates but not full, and then you charge the battery, let all of the desulfating happen and all of that, and then you're going to actually go ahead and fill the battery once it's charged, and then put it back into service. All right, battery maintenance inspection items. So you're looking for loose hold downs, number one. Number two, defective cables. Number 3, damaged terminal posts. Okay, so damaged terminal posts. Number 4, loose connections. So your lead connection up here being stripped out or not correct. Clogged vents. So these battery vents up here being clogged. Number 6, corrosion. Okay, so corroded terminals, corroded cables. Dirt and moisture on top of the battery. Okay, dirt and moisture on top of the battery can cause a surface discharge, can cause a path from positive to negative, and it'll just sit there and heat up that water and that dirt and actually cause a parasitic draw on top of your battery. And then, so dirt and moisture, we're looking for that. And then a cracked case. So this can actually happen. You can actually have batteries swell to the point where they crack or hit a bump and crack a case. So you want to be very careful of all that. All right, recombination batteries. They are basically going to keep the water getting back into the battery so we don't lose it. They're spill-proof. Individual cells with through the partition connectors. And so we'll talk a little bit about these recombination batteries. These are your spiral style batteries. All right, charging current decreases as battery charges. So the charging current decreases. So when you hook up a dead battery to the battery charger, most battery chargers will go to 40, 50 amps. They'll stay up there. And then as the battery gets charged, it's going to decrease. Okay, and that's how automatic battery chargers work, and they sense how much they had to charge from the beginning. And when they start to get down to the low side, they start putting out less and less amperage into the battery. They will automatically shut off. All right, I'm going to let you guys read through the summary. I'm glad this was a kind of a little bit more of a quick one. It wasn't nearly as long as the last couple. Read through these. Make sure you're getting the gist of what's happening here. Remember, we're going to cover this again in lab, so don't be scared, but try to get the information as best you can, and bring your questions to lab, please. Have a good day.